Hello friends, welcome back to my YouTube channel. I am Lohit C, pursuing my BE from Sri Venkateshwara College of Engineering at Bengaluru. My USN is 1VE23CA027, semester, third semester. So section DEVO and course code is BCS304 and the course title is Data Structures and its Applications. So topic for today's presentation is going to be on sparse matrix and multiplication of sparse matrix. So getting into the video, sparse matrix. So the matrix is a rectangular array of elements arranged in rows and columns, as you all know, guys. So the number of rows in the matrix is represented m and the number of columns by n. So the matrix with m rows and n columns is referred to as an m cross n matrix, pronounced by m by n. The total number of elements in m by n matrix is the product of m and n, so m into n elements. So if the number of rows is equal to the number of columns, then the matrix is called as a square matrix. Called, for example, the matrix with 5 rows and 3 columns is called as a 5 cross 3 matrix, and the another matrix with 6 rows and 6 columns is a 6 cross 6, that is 6 by 6 matrix. So is also, which is also known as a square matrix, since the number of rows is equal to the number of columns. So as we can see here in the figure 1, there are 5 rows and 3 columns. In this figure B, there are 6 columns and 6 rows. So this is the figure B is the square matrix. Next, what is sparse matrix? A sparse matrix is a type of matrix where most of the elements are zeros. Most of them are zeros. In other words, it contains very few of the non-zero elements compared to as its total size. Compared to the total size of the matrix, only few of the elements are zero. So we can here the example for sparse matrix is, this is an example for sparse matrix. It is a 4 plus 4 matrix. Most of the elements are zeros. So only 3, 7, 9. So in the first row 3 and third row 7 and fourth row 9 are the only the non-zero elements. So few of them are non-zero. So the important note is here, the sparse matrix can be represented in one-dimensional array, two-dimensional array, and three-dimensional array as well, where the sparse matrix is represented in two-dimensional array as shown in the figure. So as in the figure B, where more space is wasted. So when we represent in a two-dimensional array, including the zeros, the more space will be wasted. For example, we are considering an example. Consider a sparse matrix necessary to store a 1000 cross 1000 matrix that has only 2000 non-zero elements. So the corresponding two-dimensional array requires space for 10 lakh elements. So when we sort it in the two-dimensional array, we need a space for 10 lakh elements. So the better choice is to use the representation only represent in which only the non-zero elements are stored, so that we can, instead of storing 10 lakh elements, it's easier to store 2000 elements, right? So we are using two non-zero elements for the storing of elements. Next, sparse matrix representation. So the element within a matrix is characterized by using the triple, that is, first we are considering the row and next column, and we are putting the value on which is non-zero element. So this means the array of a triple is used to represent the sparse matrix. Next, organizing the triples so that the rows indicates as an ascending order. The operations should terminate, so we must know the number of rows and columns and the number of non-zero elements in the matrix. Then implementation of create operations as below. Sparse matrix create matrix row comma matrix column. So define matrix max terms. So we are defining the max term 101. Then type def, we are using the structure here. So we are defining the values, that is the int column. So since we are columns will be in the integers, so we are defining with integers. So int column, int row, and int value terms. Then terms, so we are defining the max terms. So this is the representation, the step-by-step representation, the sparse matrix. So first figure is sparse matrix stored in triples, and a transpose of transpose of matrix A is figure B. Next, sparse matrix multiplication. Sparse matrix multiplication is the process of multiplying the two matrices when they are majority of non-zero elements, but to make the operations more efficient, only the non-zero elements are considered. So even though there are majority of zero elements, we are considering only non-zero elements for the multiplication for the for easy calculations. By multiplying two matrix, the result of the matrix C of ij in the matrix of in the resultant matrix C is computed by summing. up to the product of elements for a row I of the matrix A and J of matrix B. However, the sparse matrix multiplication, the idea is to only focus on the non-zero elements, as multiplying the anything with 0 by 0 gives 0. So this here we have the example matrix A and matrix B. In the matrix A we have 0 0 3 0 2 0 1 0 0, and in the matrix B 0 5 0 0 0 2 4 0 0. So step by step multiplication. So matrix A is 3 cross 3 matrix and matrix B also 3 cross 3 matrix, resulting in the matrix C, which will be also 3 cross 3 matrix. We multiply rows to the matrix A with the column of matrix B. So we are multiplying these rows with the column of matrix B. But we skip the non-zero elements for efficiency. So in the example, we are multiplying the two sparse matrix A and B. Both are three custom matrix. Instead of multiplying every elements, we focus on only non-zero elements. For instance, matrix A as matrix A in the third value. See, we can see here in the third value. So in the third value, we have non-zero elements. So for that one, its position is 0 comma 2 0 comma 2 0 comma 2 multiplies with the value of fourth position of matrix B 0 2 comma 0 2 comma 0 2 comma 0. So the resulting in a 12th position 0 comma 0 in the output matrix. Then simply the value of your value at the position 1 comma 1 of matrix A with the 2 at position 1 comma 2 of the matrix B gives 4 at position 1 comma 2. So the rest of the elements remain 0, making the more efficient, making the process efficient by multiplying the non-zero elements. So efficiency in sparse matrix, instead of performing the multiplication on every element in the matrix, we will only multiply the non-zero elements, which reduces the number of operations significantly. In traditional matrix representation, we would perform m into n, p into m into m into n into p. So this is the main formula operations. And however, with the sparse matrix, the operations are reduced to only the non-zero elements, making it more faster when the matrix is larger, most most filled with zeros, mostly filled with zeros. So by avoiding the unnecessary calculations including zeros, sparse matrix multiplication save both time and computational resources. This is especially useful in the field of significant computing, data analysis, and machine learning, where matrix can be very larger, but only a small fraction of elements are non-zero. By focusing only on non-zero elements, we ensure the multiplication is performed in the most of the efficient way possible. Next, looking at the conclusion, sparse matrix play a crucial role in computational efficiency, participating in applications where the sparse matrix contain a large number of non-zero elements. Large number of zero elements. By focusing on storing and manipulating only the non-zero elements, sparse matrix representation efficiently reduces the memory and computational overload. So the traditional matrix operations such as multiplication or addition we become can become very insignificant while dealing with matrices that are mostly filled with zeros. Sparse matrix techniques solve this problem by representing the matrix using methods like arrays of triples or the concept of format that capture only the essential non-zero elements. So we have two concepts to solve this sparse matrix. That is array of triples. So array of triples we have solved using this method now. So that is first we are considering the rows, columns, and then the value of that one. So and then we have another format of concept, that is capture format concept format that capture only the essential elements, that is only capturing the non-zero elements. In conclusion, sparse matrix allow for more efficient data storage and fast computational by layering the structures of data, focusing on meaningful values like discarding non-zero elements. As a result, they are fundamental to optimize the operations in many real world application involving the large sparse data sets. So this is for sparse matrix conclusion. So thank you one and all for watching our video. Please do subscribe our channel for such more informative educational videos. So thank you one and all.